Oh, good morning, good afternoon, good evening. Welcome to Implement and Manage Analytics Solutions. Get certified DP 700 data engineer from Synapse to Fabric. My name is Thomas LaRock, and with me is Andy Cutler today. Andy, would you like to introduce yourself?
Hello, yes, my name is Andy Cutler. So current data platform MVP. There's all my socials. There's LinkedIn. I mostly blog at serverlesssql.com. As you can imagine, I started with Synapse serverless and I work for Data High.
Okay. Welcome, Andy. Good to have you here. My name's Thomas LaRock. I'm also a Microsoft Data Platform MVP. Those are my current socials. You can find me on Blue Sky, LinkedIn, and I still sometimes blog. I used to blog a lot more, not as much. I'm currently a manager for a data engineering team at a company called Blackline. We do accounting software as a service. So if you've heard of us, that's great. If not, you should look us up. Let's see. The moderators. All right, I'm going to try to pronounce this correctly. Taub Ali. Now, if I didn't do it right, he can come and correct me later. I'm pretty sure I know Joey. I've known him for probably 15 years or more now. Joey D'Antoni, both Microsoft Data Platform MVPs. They will be moderating, and I believe they're on the YouTube chat. So if you're watching this stream through YouTube, you can interact with them. Andy, this is over to you.
Okay, thank you, Thomas. So this series is split into two parts, really. We're concentrated on the part that's taking you from DP203, the Azure data engineering, into the world of Fabric and the DP 700. And there's another series that's concentrating on coming straight to Fabric and the DP 700. But what we're doing is, me and Thomas, we're working on the first part today, which is the implement and manage analytics solutions. We've got two other parts to the exam, and then the final part, which is preparation for the exam day and the open Q&A. So treat the first three parts as the content for the exam, and the fourth part as how you're going to prepare to take the exam itself. Now, of course, what would be, and I think, what would be Microsoft Fabric without a conference? Mm-hmm. So running from March the 31st to April the 2nd over in Las Vegas. Yes, that's the United States. There's FabCon. First FabCon was a year ago in Vegas. It was fantastic. It really was. There is a European version as well. There's a code. Register now on the aka.ms link, and hope to see you there. Now, yes, there are some costs that come with doing certifications. Microsoft have got you sorted. We've got a discount. We've got 50% discount on DP 700. That's running for well over 2 months. So it's going to finish at the end of March the 31st. So go to aka.ms/GC DP 700, fill in some details. You're going to get 50% off that certification, which is great. Great news.
It's a good deal.
And yes, as Thomas already said, we want to keep it interactive in the chat. We have our great moderators in the YouTube chat. Feel free to ask questions. Those guys have got you covered. Really have got you covered.
Okay. So let's dive right in. And as Andy had mentioned, this is one of a series of presentations to help you prepare for DP 700. In this series, we're going to guide you to basically understanding the DP 700 Fabric Data Engineer certification. Now, the series was designed with Azure data engineers in mind, particularly those familiar with the DP 203 certification. Now, both exams are for data engineering skills, but they focus on different scopes. So DP 203, the one you're most likely familiar with, that's a broad certification covering a wide range of Azure services for end-to-end data engineering. But the DP 700, well, that's specialized, zeroing in on specifically Microsoft Fabric and highlighting its unique tools and capabilities. So if you're ready to transform your expertise from Azure to Fabric, you're in the right place. So we're going to be using the DP 700 study guide as our guide throughout the series. And today we're covering just those first set of skills: implement and manage an analytics solution. And you can see the breakdown here of how the exam is broken down into basically roughly 3 equal parts: the implement and manage analytics solution, what we talk about today; ingest and transform data; and monitor and optimize an analytics solution. So what we're going to cover today, we'll dive a little bit into specific skill comparisons between DP 203 and DP 700, give an intro, high-level intro to Microsoft Fabric. We will talk about and understand and manage a Fabric environment. We will discuss ingesting and storing data in Fabric, integrating data sources in Fabric, and we'll end with some practical tips for success. And Andy, over to you.
Fantastic. Thank you, Thomas. So yes, this is an evolution of an existing certification. So the DP203, the Azure Data Engineer Associate certification, is being deprecated. So I think that deprecation is happening in a few weeks' time. So you might think, well, what now? If I'm moving to Fabric, if I'm working a bit more with Fabric, what's the expectation there on the skills that I need to know? How much of it is transferable? So if we move on, what we can see is almost an even split. So if you look at the overall structure of these certifications, they're targeting the same processes. We want to design storage systems to meet the needs of our analytical solutions. We want to be able to ingest and process data. We want to be able to secure that data. We want to be able to monitor it and deploy. So there's a lot of crossover in terms of the overall process. So you're not having to think of wildly different ways of doing things. It's just going to be the technology that you're using. So if we move on, now there's a lot of stuff here on this slide. I'm calling out things like implement a partition strategy. So anyone that's done DP 203, there's multiple ways of doing that within the services available. We have dedicated SQL pools, and the way that we distribute data and the way that we partition tables for optimum data warehousing and analytics, but also in the data lake. What's an optimum partition strategy for structuring data in your Azure Data Lake Gen 2 account? We've got the exploration layer. So when we're creating tables, views, and SQL around that. And bearing in mind that the technology in the DP203 was across Synapse Analytics and using dedicated SQL pools, serverless SQL pools and Spark pools, but also Azure Data Factory, so a standalone service. So how are we ingesting and transforming data using Azure Data Factory, the batch processing? When we're looking at stream processing in DP203, we had streaming analytics and event hubs. And hold that thought about real-time when we look at Fabric. And then again, security. What are the layers of security that we can add in Synapse across dedicated, across serverless? And ultimately, how are we going to monitor, or how did we monitor those systems in Synapse? So looking at pipeline monitoring, looking at SQL requests and Spark requests through Synapse and Synapse Studio. And then if we bring up DP 700, there's going to be some similarities. Okay, yes, we are moving Synapse out of the equation because now we're in the world of Fabric. We're in the world of Lakehouses and warehouses and KQL databases. We're going to start with the top level configuration of Fabric itself. What's a tenant? What do you mean by a domain? A workspace. These are the ways in which you're going to deploy and work with items, work with workloads within Fabric itself. We'll have a look at those settings. In terms of ingestion, we've got Data Factory. So all of that knowledge that you have about Azure Data Factory and Synapse pipelines, you can bring into Fabric Data Factory. Not going to lose any of that knowledge, right? You're not going to have to start again. Yes, there's a few little differences, but if you are used to Data Factory and you've done DP203, you should be able to move into Data Factory in Fabric. And then choosing data stores, Lakehouses and warehouses, and the real-time analytics as well. And we can monitor. Okay, so how do we monitor Fabric items and optimize performance and identify and resolve areas? So that's a kind of a few minute snapshot of comparing the 203 and the 700. So what I want to emphasize is that if you're familiar with the DP203, come into the DP700. The water is nice, the water's warm, you'll be fine. Okay. And yes, so when we're looking at the scope of the services, there's a lot of services in Azure. There's also a lot of data services in Azure. So when we were looking at 203, what are we concentrating on? So there were really several main services that the DP203 concentrated on. Yes, we had Synapse Analytics. We had Azure Data Factory, Event Hubs, Streaming Analytics, Azure Data Lake, and some Azure Databricks in there as well. So we had these discrete platform as a service components to look at when we were doing DP203. In DP700, yes, it is a software as a service platform, but there are still discrete components. We can still understand what Lakehouses are and what role they play, and warehouses and real-time KQL databases. We can understand what we should use in what scenario. And again, primary focus. Look, DP700 is for data engineering in Fabric. Fabric is a platform for providing an end-to-end analytics solution. DP203, it covered services that did part of that journey. Mm-hmm. Okay, but again, I want to stress the whole tooling side of things. If you're used to Data Factory, if you're used to PySpark for processing data frames and writing back to the data lake, you're going to be happy when you start looking at DP700. And yeah.
Sorry.
So I'm going to hand over to Thomas now.
Sorry, I pressed down too soon on you there, Andy. So now that we understand, that's a great overview Andy just provided of the differences between the two exams. We're going to dive a little bit more into the content, and we're going to start with a bit of level setting. So if some of this happens to be a review for you, please feel free to add your thoughts, in the chat, and experiences with Fabric in the comments as well. So in this section, we're going to discuss, what Fabric is, why it's important. We'll give an overview of the Fabric components and architectures such as OneLake, Data Factory, etc., and emphasize what makes Fabric a unique, platform compared to other platforms in this space. So scalable analytics, as someone, I manage a data engineering team, and let me tell you, complex, fragmented, expensive, those are all good words to describe when it comes to being a scalable analytical platform. But with Microsoft Fabric, you don't have to spend a lot of time combining various services from different vendors. That's really the strength of the Fabric platform. You get everything you need all at once in a single product that's easy to understand, set up, create, and manage. Fabric is a unified software as a service offering, and all of the data is stored in a single open format called OneLake. OneLake is Fabric's lake-centric architecture that provides a single integrated environment for data professionals and businesses to collaborate on data projects. Think of it like OneDrive for your data. OneLake combines storage locations across different regions and clouds and puts it into one single logical lake without moving or duplicating your data. Data can be stored in any file format in OneLake and can be structured or unstructured. For tabular data, The analytical engines in Fabric will write data in Delta format when writing to OneLake. All engines will know how to read this format, and they will treat Delta files as tables no matter which engine writes it. There's additional important features such as Copilot. It's a huge benefit for AI-driven assistants. If you haven't been using Copilot, I think you're missing out. OneLake is another important feature. You will enjoy unified data storage that we already talked about. It's built on top of Azure Data Lake storage, and the data can be stored in any format. And another feature is Purview. This is a build slide. One copy, okay. Purview, which ensures data governance and compliance. There's integration and benefits. You will experience a unified architecture that simplifies data operations. You will enhance productivity with a seamless user experience, maintain data integrity and security with robust governance, and support various data-driven applications with a comprehensive business model. Open at every level. OneLake can support any type of file, structured or unstructured. All data items, for example, data warehouses, lakehouses, they will store their data automatically in OneLake in Delta Parquet format. Data engineers can use the tools and languages of their choice to contribute to the same data lake. Compatible with existing ADLS, so that's Azure Data Lake Storage Gen 2 applications, including but not limited to Azure Databricks. You can address data in OneLake as if it were a cross-organizational ADLS storage account. So you have workspaces appearing as containers and different data items appearing as folders within said containers. So you can bring your data from anywhere, right? The modern data estate, I think we're all familiar with this. Your modern data estate is simply sprawling. It spans across multiple clouds, accounts, databases, domains, engines, you name it, it's probably part of your data estate. And that can make it hard to gain insights from your data because it's all over the place. But with Microsoft Fabric, they've simplified how you bring data into OneLake through two key Fabric capabilities: shortcuts and the new data replication capability simply called mirroring. Shortcuts enable your data teams to virtualize data in OneLake without having to move and duplicate it, right? It's just a shortcut to where the data actually exists. And you'll use shortcuts to combine data spread across different clouds, accounts, lines of businesses, domains. You will combine those into a virtualized data product tailored to your specific needs. Fabric now has shortcuts for OneLake, Azure Data Lake Storage Gen 2, Amazon S3, and Microsoft Dataverse that are all generally available today. We also have what is simply called mirroring, which is a frictionless way to add and manage existing cloud data warehouses and databases in Fabric's Synapse data warehouse experience. Mirroring will replicate a snapshot of a database to OneLake in Delta Parquet format tables, keeping the replica in sync in near real time. Once the source database is attached, features like shortcuts, direct lake mode in Power BI, and our universal security model work instantly. We will soon enable Azure Cosmos DB, Azure SQL DB, Snowflake, and MongoDB customers to use mirroring as well inside of OneLake. And hopefully more data sources coming throughout the year. Andy, back to you. I think, Andy, you're muted.
We're going to look to understand and manage the Fabric environment. So as soon as we look at the next section, that will become clear, because what we're looking at here is really, it's a hierarchy that starts with the tenancy. So often in an organization, you're going to have a single instance of Fabric in your tenancy. And in fact, that's how OneLake is attached to Fabric. So you'll have a single logical OneLake instance in your tenancy. And of course, in a tenancy, there are tenant-wide settings that you can enable, disable across a variety of the Fabric services. But how do we actually run Fabric? We've got capacities. We can have one or more capacities attached to our tenancy, and capacities range in different sizes. We have F2, which is the smallest capacity, all the way up to F1048 and maybe beyond if you were very nice and spoke to Microsoft. But of course, we can create one or more capacities. And capacities offer the compute itself. It enables you to actually run the Fabric services. Now, when Fabric was announced, we got this concept of domains. So within domains, we can create a hierarchy that could match an organization structure or a team structure. So, for example, you could have a marketing domain or a sales domain or a data engineering domain. It's a way of structuring your workspaces within Fabric. Workspaces, as we said, and we can attach workspaces to domains, are where you'll actually run Fabric workloads themselves. The workspaces are the isolated areas in which you will create Fabric items, such as Lakehouses and warehouses. There are different patterns in terms of architectures. There is an architecture pattern called the medallion architecture. We set up our workspaces in different ways to meet the expectations of those requirements. So essentially, as a data engineer, if you can understand those concepts from the top level tenancy down to capacities, domains that group workspaces, and ultimately workspaces that group items, that'll give you a good understanding of how everything is structured. So on the next section, we dive into workspaces themselves, because this is where you'll spend most of your time working with the Fabric items. So you're going to need to know and get to know what a workspace is, what it does, how you can constrain it, what settings are available. So ultimately, this is your centralized environment for data engineering. It is the hub where you will create your notebooks, where you'll create your pipelines, where you'll create your items to work with data within Fabric. Workspaces are there to also help collaborate. There are permissions within workspaces to allow people and groups of people in with different permissions, what they can do. Therefore, if you have a group of data engineers that need to access certain workspaces, you'll add them into the security and they can work with those items within the workspace themselves. But also each workspace, it has data access and security. You can enable and disable security within workspaces to meet your needs across teams. Bring in certain groups into one workspace. Don't add groups to another workspace. This is your unit of security from a development perspective. In terms of environment management, so within each workspace, it's a self-contained area of compute. So we do have settings within workspaces that expose Spark settings and cluster settings. So within that workspace, we're going to be able to set up the environment to meet the needs of what we need to do. When we look at the lifecycle management and deployment processes, workspaces connect into Git. So we can attach our workspace to Git providers, Azure DevOps, GitHub, and source control our artifacts. And that includes schemas for warehouses, that includes notebooks and pipelines. And we can use Git and APIs to actually push artifacts to different workspaces when we set up our CICD and deployment processes. And of course, Workspaces, they integrate with OneLake. So there's settings within the Workspaces to enable those settings as well. Okay, so if we move on to the next section, in terms of the top level structure of a workspace, when you're in a workspace, we've got a list of items. And yes, they're lakehouses, warehouses, notebooks. We can group those into folders. So again, you can, from an organizational perspective, group your items into something that is useful and makes sense in your organization, whether it's by team, whether it's by item type. We need to create items. So we've got the ability to create new items, and that'll bring up a pane where you can favorite items that you use commonly, notebooks, for example, and browse all your items that are available there as well. When we look at access and the workspace settings, if we look at 4 and 5 up in the top right, we click Manage Access. That's where we're going to be able to add users and groups. That's where we're going to be able to set what those users and groups have permissions. And that workspace settings, so number 5, that's where we can configure the workspace settings themselves. And just a point on number 3, that's where we can see the licensing. We can see, is it a fabric capacity? What licensing type is that workspace assigned to? And what domain is in? So there's a little domain symbol that tells you the domain that this workspace is in. Okay, so we go to the next slide. So yes, in the workspace, we've actually got a comprehensive set of workspace settings. Now, actually, these two images are really, top to bottom in what we can see. We can go in, we can change what capacity the workspace is assigned to if we have multiple capacities. We can set up the connections to Azure DevOps and to GitHub and to GitHub Enterprise. There's caching settings in terms of OneLake. So go in and enable and disable caching for OneLake shortcuts in Lakehouses. Great addition, workspace identities. Your Fabric workspace can expose an identity that you can then use in supported Azure services, such as Azure Data Lake Gen 2. And we've got Event House. So in that monitoring, it's important to note that there will be an event house created for each workspace when you enable that monitoring. And on the right-hand side, we've got I think we've got one last piece of text to appear on that right-hand side. So we'll have Power BI. So we've got the Spark configurations. So when we want to go in and change our data engineering settings and configure different Spark pools, configure a Spark environment, this is where we can do it. We can do it through the workspace settings itself. Okay, then. So if we move on. Now, I touched on security when we talked about workspaces. We've got a hierarchy of permissions available to us within Fabric. We've got workspace roles. So there are 4 workspace roles that we can work with. And that will allow certain permissions within that workspace. If you're given administrator permissions in a workspace, you'll be able to do what you like within that workspace. Go into Lakehouses, read data, warehouses, and work with notebooks. But items have their own permissions as well. So, for example, the warehouse has SQL granular permissions. You can go in and grant users and groups specific permissions on objects, just like you would in a SQL Server database. But we've got OneLake permissions as well. So within each data item, we've got these granular engine permissions, but we've also got permissions that can read data within one lake that may give a user or a group access to the data, not just through selecting from the item itself, but also from the underlying storage. So we've got read and read data and read all. But within one lake, we do have RBAC. Now, within CICD in Fabric, we've got multiple different ways of going through CICD. As I mentioned before, we do have we've got Git integration within Fabric Workspaces. So this is where you can connect your workspace to Azure DevOps, to GitHub Enterprise. And essentially, the CI/CD will happen within the workspace. When we deploy to different workspaces, the workspace is the recipient of a CI/CD process, but it's also the source of that CI/CD process as well. Now, it's split into two parts, really. We've got the integration and the deployment itself. So the integration is done with Git. Okay, we've got Azure DevOps, we've got GitHub, and we've got GitHub Enterprise as currently supported platforms. We can use deployment pipelines to move items across workspaces. So deployment pipelines will allow you to attach deployment stages to individual workspaces. So for example, if you have a 3-stage or a 5-stage deployment process, you can attach a pipeline stage to the relevant workspace. And the deployment pipelines will manage checking the changes between the workspace, allowing you to select, well, what items do you want to be deployed across the different stages? And then deployment pipelines will manage that process. And to give you more granular power is the Fabric REST APIs. So you can set up source control within Git, and then you can use the Fabric REST APIs to commit changes, but also to update workspaces. So if you have workspaces that are connected to certain branches, you can use the REST APIs to call and update a workspace with a specific branch. So I think the next section, we're over to Thomas.
Yes, sir. Thank you for that overview of Fabric. And now that we understand a little bit more about how Fabric is organized, let's spend some time talking about how we can ingest data and store data inside of Fabric. And the purpose here is really to just introduce you to the different ingestion and storage methods in Fabric. These methods, well, they're meant to be flexible, they're meant to be comprehensive, and designed to integrate with a whole variety of different data sources and pipelines. The idea is to unify batch, real-time, low-code ingestion into one platform, which should simplify workflows while preserving the power and flexibility that data engineers need. So in this section, we're going to walk through how data ingestion works at a very high level. We'll explore the differences between Fabric and Azure Synapse Data Factory, and focus on OneLake and Delta Lake as foundational concepts. Now, remember, this is a high-level overview of data ingestion. The second episode of this series will dive much deeper into data ingestion methods. So, with Fabric, we have flexible and comprehensive ingestion capabilities, right? You can bring, as we saw and discussed earlier, you can bring data into Fabric from just about anywhere. There are several ways to do this, and each is suited for different scenarios and different requirements. I mentioned that this is meant to be flexible and comprehensive, right? The idea is to really allow a user to bring data from just about anywhere, from a variety of data sources and pipelines. So Fabric offers multiple ingestion methods, right, for different use cases. One, batch ingestion, okay? That's scheduled for scheduled data loads from relational databases, flat files, other sources. Real-time ingestion for streaming data, like from Kafka or Event Hubs. Low-code, no-code ETL for things like data flows, Gen 2 for quick, user-friendly ingestion. That is your broad ingestion capabilities for every scenario. Most every scenario will be covered by either batch, real-time, or low-code, no-code. There's also a unified tool set for ingestion. So instead of needing separate tools like Azure Data Factory, Event Hubs, custom scripts, so on and so forth, Fabric will integrate all ingestion methods into a single platform, allowing you to manage, monitor, and debug data flows directly from that Fabric workspace that we talked about earlier. Fabric, the data flows Gen 2, simplifies ingestion for users familiar, say, with Power Query. Fabric supports real-time ingestion with Event Hubs and Kafka, letting you analyze streaming data without needing separate services. This allows you to design, say, a real-time dashboard or trigger alerts directly inside of Fabric. Direct Lake shortcuts, right? Those shortcuts, no data duplication is needed. With Direct Lake, you can ingest data into one lake without copying it into Fabric. This preserves storage efficiency. And shortcuts will let you reference data from external sources like Azure Data Lake, Amazon S3, and it simplifies access and it cuts down on redundancy. Now, Python Spark for those advanced data engineers, right? If you are used to coding heavy pipelines, Fabric will allow ingestion via Python notebooks or Spark. Now, these tools are embedded into the Fabric platform, right? You don't have to go out and use something separate. There's standardized monitoring management. Fabric will centralize ingestion monitoring through its portal, which gives visibility into pipeline status, performance, potential bottlenecks. You even get built-in alerts and notifications as well. And if you're familiar with tools like Azure Data Factory, Event Hubs, or Data Lake, transitioning to Fabric is fairly straightforward. Similar ingestion patterns and common languages like T-SQL, Python, Spark. It means you don't have to start from scratch and learn something new. All of that's inside of Fabric it's a composition of existing tools and services that you've probably been using for a while now. There are diverse storage options. So Fabric provides a wide range of storage options, from data lakes and warehouses to SQL databases to streaming solutions, right? OneLake is a unified platform acting as a central hub, allowing seamless integration across all storage types. And this allows for a lot of flexibility because you can choose the storage option that is right for your workload, and whether that's transactional, batch, real-time, or just exploratory. Lakehouse combines the benefits of data lakes and data warehouses. You've probably heard of Lakehouse by now. This supports unstructured, semi-structured, and structured data. So the idea of a lakehouse, it's supposed to be ideal for data engineering and data science tasks, right? The development interface includes Spark notebooks, Spark job definitions, allows users to perform complex data transformations and analysis. And you also have security features such as row-level security and CLS ensured data protection. There's a data warehouse, a traditional data warehouse designed for large-scale analytical workloads and supporting structured and semi-structured data such as JSON. It offers high-throughput data ingestion and advanced security measures, just as we mentioned before, row-level security, column-level security. Development interfaces include SQL scripts and Spark notebooks as well. There is the familiar SQL database. The SQL database in Microsoft Fabric is suitable for both transactional and analytical workloads. It will handle structured, semi-structured, and even unstructured data. It can manage up to 4 terabytes of data and offers development interfaces with SQL scripts and KQL. I can never pronounce KQL. I don't know. The SQL database incorporates high-level object-level security, row-level security, column-level security, and ensuring robust data protection and compliance as well. And lastly, the Event House, the KQL, your Custo. The Event House is tailored for real-time data processing, making it suitable for high-throughput, low-latency scenarios, supporting unstructured, semi-structured, and structured data. So those are your storage options inside of Fabric. Again, looking to provide flexibility, scalability, and security for whatever your processing needs. So you basically, all you have to do is, well, you got to choose an ingestion method. And in order to do this, these are the considerations you must take into account, right? So first, data volume. How much throughput do you really need? And everything I mentioned here, you also want to think about what are your needs today and what will your needs be 6 months and a year from now. Designing for today is not necessarily a bad option, but it's a good idea to keep an eye on what things might look like in the very near future. So data volume is one thing. What's the volume today? What's it likely to be? For high volume, you're going to want to choose a method that supports a high throughput. And for low to medium volumes, you might get away with just data flows and shortcuts to get started. Data types, for structured data, you want methods like data pipelines, data flows, and copy. But for semi-structured and unstructured data, you should consider using notebooks or lakehouse ingestion. The frequency of your ingestion, right? For batch processing, that's suitable for data pipelines, but real-time processing, you're going to want real-time intelligence, event streams, and event house. Now, what's your skill set? What's the developer persona? Are you, say, code-free? Then data pipelines, data flows for users with limited coding skills, literally drag and drop. Or is some coding required? Then notebooks, copy with Transact SQL, or custom ingestion scripts. What are your integration needs, right? What's cross-warehouse integration? That's for scenarios requiring data movement between different warehouses. What's tool compatibility? Ensure the ingestion method integrates well with other Microsoft tools. So you're going to have some specific needs when it comes to building these integrations and ingestion methods. How about performance requirements? Of course, everybody thinks you need the most highest performance possible. Well, if that's the case, you're going to want copy and event streams for low latency, high throughput ingestion. For moderate performance needs, data pipelines and data flows for general purpose ingestion should probably be enough. Complexity of data transformations, right? Simple transformations, data flows and copy will probably be enough. But for complex transformations, notebooks, Spark-based methods for advanced data preparation. Next, we have to choose a data store inside of Fabric, right? You may notice that these considerations look similar to the considerations for ingestion methods. There's a reason for that. As you're designing any analytical solution, you want to think through all of these considerations comprehensively, making sure you're using the right tool for the job and probably also the right people for the job. When choosing a data store in Fabric, you'll evaluate factors like data volume, data type, and organization, just as you would done in the past. The difference now is all your options are unified under one roof. This makes it easier to align with your team's skill sets, performance needs, latency requirements, whether for real time or batch processing. With seamless integration and robust security, Fabric allows you to optimize workloads while simplifying your decision-making process. So choosing that data store, the considerations like data volume, capacity, scalability, right? Determine if the data store can handle your current and anticipated data sizes, and see if the store's ability will scale with the growth of your data, because data is only going to grow. It's never going to get smaller in footprint. It's only going to grow. So data volume is a huge consideration at almost every step of the process. Now, what type of data we're working with, right? Structured, semi-structured, unstructured. Depending on that, like structured data is more likely going to go in the relational database or a data warehouse. Semi-structured, that's usually, we're talking JSON and XML formats. Unstructured is probably best managed in data lakes or lakehouses. Developers' personas, right? Data engineers, people probably using Python, Spark, or SQL. Data scientists, they're probably going to favor stores that are compatible with Python or R. And app developers could require integration with application development tools. How about data organization? How about schema management, right? Evaluate how the store will handle databases, schemas, and tables. Maybe it's just file structure. What if the store does or does not support organization by folders and files, if that's necessary? Read and write operations. So query languages, how are you going to interact with the data? You're going to use T-SQL, Spark SQL, KQL, or is there a different language required? And what about the write capabilities? You're going to want to support for batch and streaming data ingestion. Security is fairly important. What kind of security are you getting, or what kind do you need? You're going to want to think about access controls and compliance. And don't forget integration and accessibility, shortcut support, cross-item queries, also important considerations. How about advanced analytics, right? So do you require the need for analytical functions? Do you have built-in capabilities for complex data processing analysis? Machine learning integration, check for compatibility with AI and machine learning tools. What about latency for your ingestion? Is there a need for real-time? Will the store support immediate data availability for real-time analytics? Or is it batch processing that you need? And will your data store support scheduled data loads? Lastly, operational considerations, maintenance requirements, understanding the level of management and maintenance needed, and performance optimization. So you'll want to look for features that support automated tuning and indexing. Fabric has this all. Andy, it's back over to you to talk a little bit more about data sources.
Thank you very much. Okay, well, so you've gone through the process and you've decided which data store or data stores you're going to use. How are you going to get your data into Fabric? So in this section, we're going to look at integrating data sources in Fabric, what methods are available, and the core concepts of each of those methods. So if we move on, what we'll see is that we've got two items under Data Factory. So we've got data flows, Gen 2, and pipelines. Now, really, anyone who's been familiar with Power BI and Power Query, this is going to be quite familiar. So this is the ability to take a data source and to transform it, to do data transformation within a data set. Now, this is the low to no code version of working with the data. The fundamental change within Fabric is that we can write the data transformation out to a data store, like a lakehouse, like a warehouse. And there are hundreds of connectors, out-of-the-box connectors within data flow. So it really is your citizen data engineer can use data flows. When we look at pipelines, now this is where we can do a variety of things within pipelines. The two main things that you can do are orchestration. So this is where you can sequence what you want to do in your data flow operation, your data loading operations. But it's also got ingestion capabilities as well. So we've got items like copy data, which provide a method of connecting to a variety of data sources and bulk loading data in minimal transformations, but that's how you get your data into Fabric. And data pipelines, they essentially, you can sequence activities together to meet whatever you need for your data flow operation. So like I said at the beginning, if anyone is familiar with Azure Data Factory or Synapse pipelines, you're going to be comfortable here. Yes, there's a few connection differences and there's a few option differences that you'll have to gen up with in the study guide and the materials. But other than that, if you're familiar and comfortable with Data Factory, you should be familiar here. But that's not the only way that we can work with data. We have notebooks. This is our code-based solution for loading and transforming data. So within notebooks, we can write PySpark. So anyone familiar with writing data frame operations, loading data into data frames, writing that to Delta tables, creating functions, this is where you'll do that within Fabric, but also write SQL as well. We also have real-time analytics because, yes, it is a type of ingestion. We actually have some more details on that in a slide later on, so I'm not going to cover real-time analytics too much now. But if we move on to the next slide, we basically jump into pipelines, right? As I said before, this is a way to trigger processes, to sequence. It's your way of creating a DAG. You're putting together your sequence of events in a graphical interface. Now, we use activities within pipelines, and those activities are what drive how a pipeline acts. They are split into two main categories of pipeline items. We've got the data transformation activities. So we've got copy data. So copy data can connect to a variety of data sources, including on-premises SQL Server through an on-premises data gateway. We've got data flow activities. If we have created transformations within Dataflow Gen 2, we can sequence them here. But also control flow activities. So if we want to do metadata-driven operations, if we want to do for each, for example, and do looping, this is where we can do that within pipelines itself. Now, within pipelines, we do have parameters. So we can parameterize our pipelines, and that also includes parameterizing notebooks. So we can run notebooks and sequence notebooks within data pipelines and push parameters down inside using those pipelines. Okay, so if we move on to the next slide, and we spoke about Fabric notebooks. This is where you can bring your knowledge about writing code. We can write PySpark, Scala. I don't remember having any Scala questions in the exam, so I think you'll be fine with PySpark. And SQL. So again, if you're familiar with some basic data frame operations within PySpark, for example, using spark.read to load a data frame and spark.write to write that data frame out, then you'll look at how you do that in the context of a lakehouse and OneLake. But with notebooks, yes, we can also schedule notebooks. We can do that within data pipelines, but we've also got scheduling that we can do within the notebooks themselves. And of course, any library that we want to use and bring in, so it could be a custom ML library or an AI library, we can bring that within notebooks. So in terms of DP700, when the questions are asking you for different ingestion and transformation processes, think of notebooks as the code-only solution and data pipelines and Dataflow Gen 2 as the orchestration and no to low code area. And I think the last slide on this section is RealTime, which gets its own dedicated set of items within Fabric. If anyone is familiar with event hubs and streaming analytics, then coming to Event Stream, there are again some differences, some changes, but you'll be able to get up to speed and comfortable reasonably quickly. In event streams are where you can connect to real-time data sources. So you can connect to Azure event hubs and IoT hubs. But also with the enhanced capabilities within Event Stream, you can create your own endpoint to send data to. You don't have to spin up another service to be able to do that. Now, of course, event houses, this is where you store the data. And as Thomas spoke to earlier about choosing your data store, this is for event-driven data, telemetry, time series data that you want to track over time, because KQL, or Custo Query Language, very powerful language for analyzing time periods over a stream of data. So there are KQL commands and windowing functions within KQL that analyze data over series of times. Well, we've got KQL query sets. So this is where we're able to write our KQL statements. So we'll need to understand KQL statements like summarize and take. So a basic understanding of the top level KQL commands is very useful as well. We do have our own real-time dashboards that we can create that are separate from Power BI. We can build dashboards based on data that's available within event-houses. And then the last piece is we have Activator. So Activator is the service that does something based on an event in your event stream or a condition. So for example, if you're analyzing telemetry data, you can activate something based on an outlier. So data activator is where it'll analyze, and that could be averages, it could be mins, it could be maxes, and it'll do something. You can configure it to send an email, to post a Teams message, to activate a Fabric item, such as a notebook or a pipeline. So Activator works with the real-time solutions within real-time analytics.
All right, Andy, thank you so much. We've got about less than 4 minutes left, so I'm just going to do the speed round. Practical tips for success. So let's go through fairly quickly. Let's see if we have time for one question at the end. Some practical tips for success. So first is tip 1, leverage the familiarity with DP 203 concepts. So there's a lot of overlap between DP 203 and 700. So you would want to emphasize differences like Fabric's integration with OneLake. So pay attention to where, where the content overlaps, but pay attention to where Fabric does things a little bit different. Get hands-on with Fabric, set up a trial. It's easy to set up a trial environment to explore Fabric's capabilities and get started doing a small little project like ingesting some sample data, create a basic pipeline. Focus on T-SQL, right? And recommend brushing up on T-SQL skills, which are critical for querying data in Fabric environments. Utilize official Microsoft Learn modules, right? Go to Microsoft Learn, go through the modules, go through the knowledge checks and exams that they have there. Build confidence through projects, through practice and projects, using real-world scenarios to replicate common exam tasks, such as how do you set up a pipeline? How do you monitor for performance? How do you integrate some data sources? So anything you can do that would mimic those types of things, those exercises would be great, right? One note about the Fabric trial, it does require a per-user Power BI license. So you're going to want to be aware of that. And once you have that free license, you can begin participating in the Fabric capacity trial. And you may already have a license, but you don't know it. That's kind of outside the scope of this last 2 minutes. I think we have time for one question. I have a question here, Andy. The question is, do I have to learn KQL?
Ooh, okay. I suppose that's like, do I have to learn SQL? So when you go through the Microsoft Learn material for real-time analytics, it has KQL in there. I believe that that will be enough to do the certification. So when you're looking at KQL, you want to learn how to select columns, how to filter, so filter conditions, how to group by and summarize data, and how the time series window functions work. So there are different keywords in how to look over a certain amount of time within KQL. So I think, yes, I think some basics in terms of selecting and filtering will be enough.
Good to know. I would say you want to learn KQL if you're going to be doing anything with real-time analytic processing. anything streaming, KQL is pretty powerful for that. So it's a good thing to be aware of. But like what you just outlined, knowing for the exam itself, I don't think they're going to throw things too complex, but you should be able to understand, like Andy said, some of the basics. Okay, we're back with the slides. So the next next one is tomorrow, which is ingest and transform data. We are not doing that one. Somebody else is doing that one. Or are you doing that one? I'm not doing that one. I don't know who's doing that one. Again, you mentioned FabCon from March 31st to the 2nd of April. Go to aka.ms FabCon 25 DP700 to get more details for that. And don't forget the 50% discount for exam DP700. Go to aka.ms GC DP700. Fill out the form, get yourself some free money. And questions. So you can find resources at these links, and we can continue the conversation at aka.ms forum DP700. And with that, I believe we are at time and we are complete. Andy, thank you so much for your time today. It was great doing this. We should do this again.
We should. Thank you, Thomas. That was fantastic. I just want to call out, yes, that Fabric community link. That's where you can register, ask questions. Hey, post replies, get involved. It's a really, really great community for posting questions and receiving replies as well. So I highly recommend people look that up.
All right, thank you. And for this session, I was Thomas LaRock, and thank you, Andy, again.
Thank you very much.
Oh, I have to wait.